This video is about streams in functional programming. A stream is a sequence of elements that come from some data source. You can perform operations to modify the contents of a stream or examine the contents of a stream, and then at some point you perform a termination operation to end your modifications to the stream contents. What can you do with a stream? There are lots of things you can do. You can print each element of it, you can combine the elements, aggregate them, sum them, search them for things, combine them in various ways, etc. Streams are a little bit like collections conceptually, except you don't hold the whole stream of all of the elements in your hands at the same time. You sort of look at each element in the stream as it comes in. So in that sense, it's a little bit like an iterator or a for each loop, where you're handed the next element continually until there are none left. But the other thing that's important that's different about streams compared to things like collections and iterators is just the thought process and the way that you process these streams. Streams are functional in nature, and therefore you often interact with them using functions, using lambdas, using operations that are passed in as functions that manipulate the stream, as opposed to something like an array list or an array where you loop over the elements and access element I, and you write your own code iteratively to process the elements. These kinds of traversal and mapping and applying elements to each, applying operations to each element of the data set, the way that you think of that is very different in a functional structure than it is in an iterative procedural structure. Let's look at a few examples of processing streams in Java. Here's a piece of code that doesn't use streams. A pretty typical procedural piece of code that computes the sum of the squares of the integers from 1 through 5 inclusive. So we do a cumulative sum algorithm. We declare a sum out here. We add I times I for each value of I between 1 and 5 inclusive. This isn't functional. This isn't a stream. This is the old way of doing things. How would you do the same sort of thing with a stream? Well, in Java 8, there is a new command called int_stream.range that you pass a minimum and maximum value, and it will return a stream that contains those values from the start value up to but not including the end value. So int_stream.range 1, 6 returns a stream containing the integers 1 through 5 inclusive. What can you do with that stream? Well, you can perform modifications on it. The first kind of modification we're going to talk about is the map modification. Map is a function, a method that you can call on a stream, and it takes as its parameter a lambda. And the lambda accepts as its parameter a single element from the stream, and it returns a new element of the same type, a modified version of that element. So in the example here, we ask for a stream of the integers 1 through 5. Then mapping applies the following conversion to each of those elements in the stream. It takes the element and turns it into the square of itself. Then, once we've done that to all the elements, we call another operation named sum, which adds all of the values in the stream together and returns the sum. So sometimes in our chapter we draw pictures of stream operations. One way you can think of it is that when you say int_stream.range 1, 6, you get this stream of things. Now in the slide here it looks a little bit like an array or a list, a collection with these square brackets. But again, I don't think you should totally think of it as a collection because we don't have some of those same operations and random access that we have on a collection. But look, those are the elements in the stream when we say int_stream.range 1, 6. When we supply the map operation with that lambda, n becomes n times n, it basically converts the elements of the stream to be these elements. 1 plus 2 times 2, 3 times 3, 4 times 4, and 5 times 5. Now the stream contains these 5 things. So these are stream modification operations. Sum is a stream terminator operation, which means that it follows a set of modifications and it condenses down the results to produce something final. So in this case, it is the same as looping over all the elements of this stream and adding them to each other. And the result of doing that is 55. If you want to use streams in your code, let's go to our editor. Streams and most of the methods and classes related to streams are stored in a package named java.util.stream. Now that we've done this, we can say int_stream.range 1, 6. That produces a stream. The most common style here is to indent as you supply operations to the stream. I could just write sum on that and I would be done. I could say int result equals that, and then I could say system out println result. How about the sum is plus result? I compile and run. It says the sum is 15. That should make sense. 1 plus 2 plus 3 plus 4 plus 5 equals 15. But again, between creating the stream and condensing the stream, terminating the stream, we can do these different operations. So I can say .map, and now I can put any lambda I want. I can say each value in the stream n becomes n times n. And we learned about lambdas in our previous video. Lambda takes parameters and produces a return value. This is a condensed form of writing a function, declaring a function here. And now the stream contains 1, 4, 9, 16, 25. Therefore, the sum has become 55. We could put any lambda here we want. It could be, you know, n times 2. And now it's 30, which is, you know, 2 plus 4 plus 6 plus 8 plus 10. I believe it's the double the value of each of those 5 elements of the stream. So that's the map stream modifier. And we call that a higher order function because map is a function and it takes as its parameter another function. So that's an important idea from functional programming, composing functions by passing other functions to them. Let's look at other stream modifiers. Here's one called filter. Filter is a modifier for streams that accepts a lambda as its parameter, but the lambda, instead of turning n into some new value of n, it is a Boolean lambda that takes an n as its parameter and produces a Boolean result of true or false, whether we want to keep that value in the list or not, in the stream or not. So in our example previously, we mapped all the ones to be squared, but in this second example, what we're doing is we're applying a filter. Here's intstream.of. This is, instead of a range, I'm just passing in a set of numbers and they become the elements of the stream. So the stream contains these, 10 integers here in this order. So intstream.of returns a stream of integers. And now I'm saying filter the integers, keep only the n's such that n mod 2 is odd. In other words, not 0, so that means the number is odd. Keep only the odd numbers from the stream. So it's going to throw away 4 and 2 and 6, and these kind of things out of there. So if you look at the picture near the bottom of the slide here, we start out with all of these things in the stream. We remove the ones that are even using the filter. Now, after doing that, we map the squaring command, and it squares all of the remaining elements. And then finally, we do sum again, so it adds them all together and produces this result of 151. So filter is pretty powerful. If we want to go back to our code here, we could change our range to be 1 to 100, 1 to 101 to include 100. Okay, well, what do we do here? Well, why don't we filter out the elements that are not multiples of 3? So how about n mod 3 equals 0? We'll only keep the multiples of 3, and we will add those together. Excuse me, I should have written filter for this, and then sum. So what does it do? Well, it produces the sum of 1683. And I mean, I'm not going to double check the math manually, but basically we're doing 3 plus 6 plus 9 plus this sort of thing. We're keeping the ones whose mod 3 is 0. That's the filter modifier. And again, you can combine them both. This one here combines filter and map. You can stack these on each other. Each one of these performs a modification on the stream. So we can use streams along with all the other things we've learned previously. Here's an example that makes a regular method, normal method, but part of the code for that method uses streams. It's a fairly simple implementation of a prime number checker. This isn't really the best algorithm for doing this, but what you could do, if you want to know whether n is prime, you could just loop over all the ints up to n and check whether n is divisible by that integer. So ask whether the count of how many of those things there are is 2. If there's 2, which would only be 1 and n, that means that there are 2 factors and therefore the integer is prime. Now this is not perfect. It doesn't work for certain values of n and so on, but that's the idea. What is this count thing? Well, there are a set of different stream terminators. I showed you max. There's also count. There's a whole bunch of other ones. You can do average. There are a lot of different collecting, terminating operations you can do to basically take the contents of the stream and condense them down into some kind of a result. So for example, if we went back to our code here and we wanted to do something like public static int sum of evens, and I'll say int max, add up all the even numbers up to that max and return the sum. Well, it would be very similar to this. You could do something like get the range of values from 1 through max plus 1, because the endpoint is exclusive, so we have to say max plus 1. Filter by n mod 2 is 0, so keep only the evens, and then sum them. So then I'll return the result. Or, of course, I don't really need this variable. I could just say return the result of doing all of that. So what's the sum of evens? Well, I could call this here and say the sum of evens is sum of evens up to 20. What's the sum of the evens? 110. So, I mean, 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20, and you should get 110. Let's look at another stream modifier. This one's called reduce. We saw map and filter. Reduce is a little bit different. Reduce takes all the elements of the stream and combines them together to produce a single result. Now, the funny thing is we already saw max and, we already saw sum and count. Those were the two stream terminator operations that we already saw. Reduce allows you to write your own stream terminator. Basically, it allows you to take all the results of that stream and just condense them down into one thing. So, what am I doing here? This is a factorial method. You give me int n and I'll compute n factorial, the product of all the integers from 1 through n inclusive, for a non-negative number. So what do? I ask for the range 2 through n, and I reduce them by taking pairs of them and multiplying them together. So if I have 1 times 2, I multiply those together. If I have 2 times 3, I multiply those together, and so on. The one thing that's a little odd about reduce is you actually have to pass two parameters. You have to pass the reduction lambda, what it does to combine neighboring pairs of elements from the stream, but you also have to pass this initial value. Because if you want to think of it this way, if you have 1 times 2 times 3 times whatever, you need something to be able to, if you're gluing these pairs together, you need somebody over here to start with that you'll start combining with all these pairs. So you need sort of a starting value. Start with 1, and then 1 plus the first element, and then that plus the second element, and so on. A little bit unintuitive at the first time you see it, but that's the way that it works. Let's write a couple of stream methods together. Sum of absolute values. Let's use stream operations to compute the sum of the absolute values of all of these integers in a stream. So if that's the stream, then the sum of absolute values should be 22. Let's copy this and paste this sequence of values into our code. So let's do sum of the values in an array of integers. Okay, so int bracket bracket a equals this. And then I want to do sum of absolute values. Sum abs vals of a. And I'll put a print statement here at the bottom. The sum of absolute values is plus sum abs. Okay, how do we write this sum abs vals method? Well, we know what the heading should look like. It should be public static int sum abs vals int array a. Okay, so basically we've been doing streams where we get started by making a range of numbers and then we apply these different operations to them. This is a little different. Now we have an array. How do I treat an array like a stream like this? Well, there's a nice method called arrays.stream that you pass an array and it'll turn it into a stream just the same way that this intStream.range method creates an array. So once we have the array as a stream, we can do all those same operations that we just saw. Okay, well, how do I sum the abs values? Well, I'm going to say sum, but that's not quite right, because first I need to turn everything into its absolute value. You could imagine doing a for loop over the array, setting each element to the math.abs of itself before you did this stuff. But that's not the functional way. The better way to do it would be to say to map n becomes math.abs of n. So turn this thing into a stream, perform an absolute value on each element, and then add them all together, and return what you get as your result. Let's try it. The sum of the absolute values is 22. That's what the slide said that we should calculate as our answer, so I think we've got it. Let's do another one. Write a method called largest even that returns the largest even number from an array of integers. So if this is the array, then we should return 12, because there's 12 right there. Okay, fine, let's do it. So we want to compute the largest even, int bracket a2 equals that, and let's do int largest equals largest even of a2, and we'll print the largest even is plus largest. Okay, so now we just need to write this method. So let's write public static int largest even from an int array a. Well, the first thing we need to do is convert the array into a stream. So let's do that. Arrays.stream of a. Okay, now what? Well, we need to find and return the largest even number. So, okay, well, we don't care about the odd numbers, right? So why don't we get rid of those odd numbers? How do we get rid of things from a stream? We filter them out, right? So let's take this stream from A and filter and keep only the n's such that n mod 2 is 0. Keep the evens. The syntax of filter can be a little confusing. Some people think, oh, am I filtering out these ones? But the filter function is a true or false test of should I keep these elements. So those are the ones we'll keep, the even ones. Okay, largest even. Well, how do I keep the largest one? Well, one thing we could do is we could reduce and keep the larger of any pair. That would be fine. But a simpler way would be to just say max. And we need to return it. Okay, so I think that if I want to show you the true answer to this, I'll say reduce. Now, how do I reduce? Well, I have to write a starting value, and I have to write a lambda that takes an a and a b. So, okay, if I have an a and a b, and we know that they're both even, how do I know which one to keep between these two? Well, let's keep whichever one's bigger. Let's keep math.max of a and b. You understand? If you pass me two values from the stream, I'll keep the one that's larger. Fine. Reduce also takes a starting value, so let's just start with 0. Basically, we'll compare the first element to 0, and it'll always be bigger than that. So let's try it. It doesn't like my use of a because the int array here is called a. Okay, let's write x and y and do math.max of x and y. That's fine. Okay. Now what did we get? The largest even is 12. There it is. Now, a moment ago, I tried to write the code by just writing .max. This didn't compile, which is why I changed the code to use reduce. In the next video, we're going to talk about what max really does and why it didn't work and why I had to write the code this other way.